Okay, we want to graph this cubic function, and I'm wondering what are the critical values, because if I knew the critical values, I could plot the local min and max. And that's how I want to approach this problem, is to first plot the local min and max on the graph. You can sketch the rest of it after we've done that. So step one here for us is to find this derivative. So you got to set it equal to 0 and factor. So when we set this thing equal to 0, I don't know if the one on the test factors. This one here doesn't, so I'm going to use the quadratic formula. I wrote down here the quadratic formula for you. I applied the formula right here for this a, b, and c, and these are the solutions to the equation where the derivative right here is equal to 0. So these two numbers, these are the critical values. I make one small simplification to this, and then I'm going to just put it in my calculator so I can get the decimal approximation. This comes out to be 1 plus or minus root 48 over 6. If you can't do this simplification quickly, then maybe you just plug this whole thing straight into your calculator to get the decimal approximation. I get that this number has a decimal approximation of 2.15. Now that's the positive version, has a decimal approximation of 2.15. The negative one, 1 minus root 48 over 6, has a decimal approximation of minus 0.15. And so, because I want to plot the ordered pairs that correspond to this local min and max, then I'm going to substitute these numbers back into f of x. I plug these numbers back into f. I just use my calculator and get these decimal approximations. We can go ahead and start drawing the graph from this. So draw your axes, label them, plot these points. This one's really close to 0, so it's right there. Its x value is right in here, and its y value is 1.92, so I'll put that point. Now this right here, this has got to be the local min, because why? Because 1.92 is less than 8.08, so this point on the graph is lower than this point on the graph. This point on the graph is over here, where x is 2.15 and the y value is 8.08. So this point is the local max. And you can easily see that when you put 0 into f of x, that f of 0 is just 2. So it must cross right there. And I can now see what the shape of my curve is. If this is the local minimum, then it has to make a bottom right there. If this is the local maximum, then it has to make a top right there. And I just will connect the two pieces. Okay. Am I finished yet? I should probably formally state where the point of inflection is. How would you do that? Well, you would do it with the second derivative. So f double prime here for us is what? Minus 6x plus 6. So that means that x equals 1 is the point of inflection. And you can see that, well, that point would be right about here. So this is where x is 1, this is where y is 2, and maybe I'll label this ordered pair right here. This is 2.15, 8.08. You can go ahead and label this ordered pair down here too. Minus 0.15, 1.92. And the graph is completed.